This week we're going to be looking at geocoding. Geocoding is the process of taking data from a table and making a map out of it. We've done this before, probably, with XY coordinates, latitude and longitude, and you'll recall that latitude and longitude need to be in decimal degrees. If they're in sexagesimal degrees, it won't work. The conversion from sexagesimal to decimal is can be a little bit arduous. But once you do have decimal degrees like this, and this is a copy of World Cities that I was able to wrestle down into decimal degrees, it's a simple matter of right-clicking and displaying XY data to get a map of all the world cities. Now, I'm not going to take you through step by step, but this is the database that I started with to get that world cities. You can copy and paste this into Excel, and each one of these things comes into a separate row. The symbols are sitting on top of the text. You've got these degree symbols and the quote, single and double quote marks indicating minutes and seconds. Well, in this case, no seconds, but just minutes. And then you have the west, north, southeast indicators for direction. And then you have some commas embedded in the fields, and what you end up doing is making a comma-separated file out of this. Okay, so first thing I would do is I take those degree symbols and convert them to commas, and do the same for the quotes and the double quotes. I'd go into the field that has the region and some of them, like Boston, Massachusetts, that has a comma in it, and I would strip out all the commas. Just leave it a space. So instead of Chicago, comma, Illinois, you'd have Chicago space, Illinois. And then I think probably there are no commas in the next field over, but I would strip out the commas and make them spaces. So in other words, you're replacing commas with spaces where they don't belong and putting commas between every value. So we would then have, say in the top row there, we'd have 42, comma, 40, comma, n. And then I replace the comma n with comma n, comma. You see why? Because I need to separate the n from the 21 with the comma. So then it would read 42, comma, 40, comma, n, comma, 21, comma, 10, comma, east. I'd do the same thing with east, so it would be comma. And then it would be Pristina space Kosovo. And then I'd add a field there and put it commas all the way down. So it would be Kosovo, comma, Serbia. And is that I have all those images. So to remove the flags, I would copy the whole thing and paste it into a notepad document. Notepad can't display symbols, so they would all just disappear. You would have tabs, though, so you'd have to copy the tab and paste it in as nothing. So you get rid of all the tabs, and then get rid of all the spaces. Copy a space, and then change all the spaces in that notepad to nothing. And then, of course, at the top row, you write in latitude, minutes, longitude, minutes, city, country, all separated by commas. So that becomes the title rows of all your fields. We're getting there, but we're not there yet, because we have those n's and e's to deal with. I would take that comma-separated file, open it up in Excel. Then all the n's and s's would be in one field, and all the e's and w's would be in another field. I'd sort by the n's, and then I would go to the s's and multiply all those fields times -1 to give a negative sign to all the southern latitude cities. And then I would go and do the same thing with east and west, finding the wests and multiplying their latitude value times -1. And then I only have to convert the sexagesimal to decimal degree. And to do that, you multiply times 0.0166666. That's converting minutes to decimal degrees, your sexagesimal degrees to degrees by multiplying times 0.0166666, and then add that on to the degrees. And here are some shortcuts. If you want to type in code, you can do this in kind of like one shot all the way down. In the end, you'd get a whole field of hundreds of cities like this. Okay, so once you have your latitude and longitude prepared, it's just a matter of display XY data, and latitude is Y, longitude is X. You can change the geographic coordinate system if you want, but I suspect that world cities are going to be in Nat 84. We only had degrees and minutes, we didn't have any seconds, so it won't be exact, but it's pretty close, and the boundary files are also quite crude, so some of these are not going to be right, but you can see that it's pretty accurate. And that was all done with a database from Wikipedia, just a list of latitude and longitude for world cities. Okay, so my PowerPoints will give you a little bit more information about that, and remember, in the end, you need to data export the event if you want to keep that layer, because it isn't a real layer yet. It's a virtual layer, so to speak. Okay, so the next thing we're going to do is look at zip code centroids. We'll do this in the next PowerPoint, in the next podcast, and see you then.